Hey, we've received multiple questions over the last year or so about Terraform file structure and organization. It's a complicated solution, but mainly because it's so dependent upon your needs and team design. However, I've distilled it down to a handful of items to help you make the right decisions. But first, let's take a look at where most of us likely start and talk about why structure is important. Just to give you an idea of what the Terraform structure might look like. So a lot of us, I think, begin in this position where you have a module root, and within that root, I have all of my files. This is just a flat structure. And if I kind of drill into something like my main TF, the main TF has all of the resources in it necessary to build whatever component it is that I'm building. And I've got some other things in here too, and I'll just briefly cover why some of these things are named the way that they are. Obviously, git ignore, if this is stored in Git, this is actually really important. If you forget to create a git ignore file and you check your Terraform code into a Git repo, you might check in the binaries that Git depends, or that Terraform depends upon, and those would be the provider binaries. Those are quite large, and you will hate yourself if you check in that code without putting in a git ignore to ignore that stuff. So don't forget that, very important. Some of the other things I have on here are a bit more optional though. I've got underscores preceding them only because alphabetically or lexicographically, I wanted them to sort to the top of the list, because they're things that, I don't know, for me, they're things that I might go to frequently, and I need them to be readily available for me to jump in and modify, for instance, the outputs, or look at what the outputs are, or add variables. And so this just makes it easy for me to get to those. And then the main is just a typical name that we use for the bulk of our configuration templates. Now, the way I've shown this, it looks kind of like a directory. It's not that. These are all just resource calls that might go into kind of a large main in this case to build out the component, as I said before. And then at the bottom, I've got a README, not critical, but I do find that it's pretty useful. And especially if you are storing this in a Git repo, then that would provide you obviously a way for others to know what your module is about, perhaps what variables people need to define for themselves, or what prerequisites you have. And then lastly, I just have sort of noticed here that there's a TF vars file. And so that would be the default location where variables are going to be ingested into the Terraform template to be used with this. You don't have to have that. And actually, your git ignore might ignore that from sending it up into the Git repo. I know in some of my cases, I actually keep that in the repo, and in other cases, I keep it out. It kind of depends upon the purpose of the repo, I guess. If I need other people to execute on it and I need those vars in that, then I might include it. But if I want everybody to have their own copy, then I might exclude it. So this is kind of, Jason, I assume this is where you have started. This is certainly where I have started. And to be fair, where I frequently return, because this is oftentimes the way that a new module looks to me before I maybe blow it up a little bit or subdivide it differently. Is that true for you?
Yeah, that's pretty typical environment. I don't have anything much different. Like the only thing I would have different that I would make sure that I would have in my git ignore is if I had a secrets file, like the auto secrets file, I would put that in the git ignore and make sure that is ignored.
Yeah, that's fair. Other things that you need to keep out of there. And that goes for any other files that maybe you have in here that are periphery elements that just don't belong in the Terraform code itself.
Mhm.
Now, I said before that I distilled this down to a handful of things. So to help you make those decisions for your team structure, for your organization structure, there are a few things that we want to cover to help you divide this. So the first of those is the change rate and the ease of management. So if we think about what we started with here, I've got just a flat structure with all of my files in the module root. But as I look at that, I realize that perhaps not all of those files are changing at the same rate. And certainly from a management standpoint, as soon as I add another module, then I'm going to need a new directory. So here I've just kind of broken it out a little bit. So now I've got like this directory here where my flat files have gone. And I have a couple of other directories where I'm going to be starting to put other BU's applications. And I think this is pretty typical. So this is just basic directory structuring. I'm going to create a new directory for every root module that I want to call. But speaking of modules, one of the big changes that I made here is I've actually pulled out all of those references, all of that that flat code that was in my main. I have now pulled those out into a modules directory. And so this is sitting above my root main. This is the modules at a new root. And I created a category or a directory for Azure, and I put all of the various Azure resources within that I might call. And the reason I did that is that the management reason, I said ease of management, might be that by doing this, I only write that code once, and then I get to reuse it for every time that I need it. So as I start to write another application out here for a business unit, then I can refer to those same things. So if I need to call the app registration, then I can simply refer to the module that's already out there that I had already written. So there's no reason for me to rewrite that. And moreover, if I later make changes to the app registration module, then the business unit that is consuming that module can benefit from those changes. Now, because it's Git, I can still use source control, and I actually put a kind of a bubble around this. All of these modules are actually stored in a Git repo. So I have the option now of doing version control on those and ensuring that I have kind of a contract going with my consumers so they can use whichever version they are, their code is suited for, and then obviously have their own plan, their own life cycle to upgrade that stuff. And one other thing I want to point out here is that I've got all of these just resource level modules, but I've also got some more, I would say, application centric modules. So it could be that rather than my business application pointing to a distinct module like app registration, it could be that I actually point them to a larger, like an app construct, or in this case, it's a cluster construct. And then that particular module actually refers to the pieces within here that it needs. So by doing it this way, what I've done is I've just kind of rolled up the dependency graph. I now have an application that can consume one module, and that module is then dependency controlled over all the modules underneath it. And this is a relatively, I don't want to say debatable, but certainly some people want to keep their module structure very flat, and others might nest it so deeply that it becomes very tedious and difficult to manage. This is probably the level at which I am comfortable nesting modules, and that's just one level. So I have one major module, and that module might call resource level modules. So this feels like an okay path for me to take. And there may be some cases, like for instance, when I call the VNet module, the VNet module may have some other elements within it. Like it might have, maybe I attach some NSGs that are readily available for subnets to sit with. Or maybe I have flow logging, for instance, created within that. Maybe I set up monitoring for log analytics at that level. So that module isn't necessarily one resource. It may be several, but they're all like very closely related, if that makes sense.
Yeah, I agree. I've seen it where, you're spending a lot of time trying to track down the different pieces. Like, why is that piece being modified? And you're digging. Like, okay, I got to go here. All right, now I got to go here. And then, oh, well, no, that's not here. And so that can, you start dealing with turtles going all the way down,
right?
And trying to find stuff. I like this where you have, it's obvious it's more of a module for multiple things. And if you're calling other modules, I can just go to the one and find it instead of trying to find oh, well, this is this region. Okay. Okay. I'm just trying to piece it all together.
Yeah, and I didn't talk much about change rate. So a lot of what we covered right now, I think, is the ease of management. But the change rate, by breaking these things out into modules and even the sub modules, kind of to what you're speaking to, some of these things may change more than others. So, for instance, my admin hub project or application that I have up here, it may experience changes a little bit more frequently as I perhaps tweak tags or some of the metadata associated with it, or maybe I just want to spin up additional VMs within that. So my rate of change here might be a little greater than what it would be for in the example of the app registration. Like, how often am I going to change the code that creates app registration? Probably very infrequently. So in this case, by pushing those out into modules, I've basically said that I'm going to use change rate as one of the indications that tells me how to break up my code. Many of you probably know this. If you're in a production environment, you don't want to make changes to things, or you don't want to bring risk to things that aren't as part of that change. So you want to keep your changes very focused to the things that are being impacted. And in order for your risk to be lower, you have to remove all the other things that could be impacted. So this gives you a way to do that. Now I can pretty safely make changes to all of the things within, in this case, Admin Hub, without actually making any impacts to the modules that it is calling. So I have a parent-child relationship here.
And that does tag into where we're talking about how deep things change, right? So if you make a change, if you have a lot of submodules, if you make a change and you have a lot of submodules, you may impact more things than you know, because, or when you do a plane, you'll see it. You're like, why is VNet changing now? Well, you changed this one parameter, and now it has a lot of consequences.
I think to your point, if I instead had two people calling app registration, right? I have admin hub, the main is calling app registration, but I also have this app sitting out here in the business unit that is calling a larger TKG module, and that module is calling an app registration module. So now if I make changes to this particular module, then I am potentially affecting multiple people. So I do have to be aware of the dependency graph that I have. However, I will say there's a couple things that happen here. So as I make changes to the modules, I now have source control that I can maintain. So I can have tagged releases that get referred to by anybody that's consuming those. This TKG module can be pinned to a very specific 1.0 version of that module. And any changes I make to it won't impact the way that TKG consumes it, because I set up a contract for that. I'll also say there's a way that you can kind of temporarily modify your structure a little bit, and to good benefit. So for instance, if I'm in Admin Hub and making changes and I'm consuming all of these different modules, I might need to make some changes to those modules, but they're experimental right now. So what I can do then is just simply add a modules directory locally within my flat file structure. And then I can source the file into the directory of the modules. So now I'm making changes to a local copy of that module. And so it gives me a chance to kind of experiment and play around with changes to that module that I could then later do a proper fork or merge request to implement this new code, and we could set it up as a new tagged version. So there is still an opportunity to effectively flatten my structure again, but it's only temporary as I make changes to something.
Hopefully.
Yeah, hopefully. Yeah, don't get stuck. I have been there as well, where you get stuck and you forget, like, why do I have this local module? What changes did I make it? What do I need to send back to the main? That can be challenging.
I had some friends who are, I would call bad children, who decided to move outside of the repo of the modules and just pull it down locally, and they just make their changes there forever. And then you're like, are you gonna push that change back out? And they're like,
right.
No.
Yeah, that's
Well, that's
pretty.
not helpful.
There's also the hidden I think it's hidden. There's the Terraform directory that's created dynamically. So as you run Terraform commands against your file structure, then you're going to get this Terraform directory that shows up, and within it, I don't remember the exact structure, but within it there's a modules directory, and then you'll have cached local copies of the module. So when you do a Terraform init, it actually copies the module from remote into this location. And it is possible for you to dip into this cache and make changes to this module, but it's a terrible idea.
Bad children.
Bad children. Yeah. I have also done this.
You're officially grounded from Terraform.
That's right. That's right. I have done this as well, and the only reason that I have done it is for break fix. So when there's a module that I'm ingesting that the contract maybe was broken, I may have to modify that module to behave the way it used to, because maybe I upgraded prematurely, or maybe they weren't using tagged releases and there's just one version of the module. So in that case, if you upgraded your module, you may need to downgrade it effectively. But this is definitely a very edge case that you would modify that.
That makes sense in that use case. And then you would lock it to your local module set, probably.
You still need to, as we were saying, kind of communicate that back out and figure out a way, probably at the very least move it into a local modules directory so that you have distinctly, because the cache copy will get updated. If you do a Terraform init -upgrade, then it will overwrite your local cache and you will lose the changes that you had. Okay, so this is change rate, ease of management. The next one, and this has come up multiple times on Discord as well, but the next one is blast radius. And within blast radius, I need to make some additional changes to accomplish that. So I still have a lot of the same structure that I had before. I've got my applications out there. I've got the various modules out there. But in this case, I'm going to break up my project, or my, what had been a flat file structure. I'm going to break it up into distinct directories. And this is a pattern that I use. And here again, I've got underscores, and this time I've got numbers, and it's just zero base. So I've got a number underscore and then the name of my directory. And what I've done here is, if we think about, it actually goes back to the very beginning. But if we think about all the things that were being built, there's a lot of elements. And so, for instance, I've got on the screen network security, ExpressRoute, and then I've got a keepers directory. Well, if we think about ExpressRoute, ExpressRoute is sensitive in Azure. That is our direct connect to the environment. And I definitely want to minimize the risk of change. Even if it's in a module, everything within a flat file, or everything within a root module within the single directory, is part of the same state. So any actions that I take with Terraform are going to affect anything within that one directory. So whether you have them in modules or you have them in a main.tf file, line by line as resources, the state remains the same ultimately. The artifact is that everything in that directory is impacted. So what I've done here is created some subdirectories, and if I have an ExpressRoute subdirectory, that means my ExpressRoute is now outside of being impacted by anything related to network security in this case, or whatever keepers is. So this gives me a way to break out pieces that, blast radius is a great term. If I mess up ExpressRoute, accidentally or otherwise, then I break my connection to Azure, right? My dedicated connection that the whole enterprise is counting on. I could potentially tear that down. And if you think about the way that Azure works and the way that Terraform works, it's going to reconcile changes. And sometimes, like if Azure sees that you want to make a change, like a name change to your ExpressRoute circuits, then it'll tear down the circuit and recreate it. And even though everything will be back up and running as it was, you will have a moment of downtime while it went through the process of destroying something and then coming back and reconnecting it. Very bad, very bad.
Well, yeah, I was going to say, I would say that is true. until it doesn't. Like you run your Terraform, yeah, it might rebuild, it might not rebuild. So don't even risk it if you're not intending on.
Yeah, I mean, you definitely need to recognize what your plans look like that indicate whether or not something's going to be rebuilt, and that's something that you can learn by just running Terraform commands and looking at the output. But this is a good structure because it gets you set up for better structured code to do all the things that have happened so far. Right, my rate of change on the express route is far less than anything else. Management might be easier because now when I go to work on the express route code, it's just the express route code, and I don't want to be distracted by other things that might exist in that main. And then of course the blast radius, we just talked about. Now there's another one in here, the keepers. This is just definitely my own invention, not something that I think you'll see on any sort of best practices guide. But in this case, what I oftentimes do is I'll create a keepers directory, and that directory instantiates the environmental elements that I need to actually run the Terraform code. So for instance, if I am using a backend state in Azure, I'm going to use storage account as my backend. I want to store the Terraform state there. Well, in order to do that, I have to have a storage account to do it. So the keepers is just a way for me to still IAC. I can use infrastructure as code to build those prerequisite elements. But since I don't have a backend yet, I can't use backend for that particular configuration. So in this case, I have keepers, which you'll notice has a terraform.tf state present in it. And that's because it's local state. It has to be. There's nowhere else to put it unless it's some other provider, but then I would have to instantiate that as well. So I have one in this case that has its own local state to generate these sort of underlaying or fundamental elements for the rest of the build to go. And we can kind of get into at some point what this code would actually do. But in this case, my blast radius is now minimized, right? Like these are the things that are going to be fundamental for everything else to execute. And I'm not going to touch those unless I need to make changes to those. And I'm doing so explicitly. So that keeps it out of the purview of change. And I can work maybe on network security, which incurs a lot more changes because of modifications to NSGs, to firewalls, to whatever, and just focusing on this area. You'll notice that I also have an env directory added here. And instead of having what we had in the beginning, terraform.tfrs, I'm now using like a westus.tfrs and eastus.tfrs. And so these are, in this case, these are just location-based variable files or user variable files. And this gives me a way to then, programmatically within CI/CD, I can call these on the command line as being my input variables for that particular run. So you can imagine that I can actually run the same code, which is great, right? Consistency, but with different variables to get a different result for maybe it's non-prod and prod, maybe it's 2 production sites. Doesn't matter, right? All of those variables would be defined in those TFRs files. One other thing that happens on here, and this becomes more important the more we start subdividing things, the more important it becomes that we're able to sort of track progress or check in with the outputs of one of the other runs. So I start using, in this case, I've got it called underscore vault.tf. And this is Azure Key Vault, and I'm using it in this case as a registry. You could use console if you're purely HashiCorp, but if you're in the cloud, you might use something that is a service-based product within the cloud. So I'm using Azure Key Vault. It's inexpensive for me to use as a secret store, and I actually get the added value of being able to store actual secrets within that with no concern about their storage. And then everything else is encrypted, unnecessarily or not, it's encrypted values, won't hurt anything. So I will use the vault then to store things that I can then recall in other steps, so that if for instance, it makes clear sense that if I'm creating network security here, if I'm creating a VNet, if I'm creating subnets, if I'm creating NSGs, I may need to recall those names or those IDs in later steps of the execution. So I can, as a consumer, I don't even have to have access necessarily to the remote state or to these files. I can call known locations within the vault as my registry target and get those values from it, no matter what they are. They can be changed at any time, and I'll always get the latest values. That's a little deeper than just strictly naming, but I think it does warrant discussion because, as I said, as you break these things up, you find yourself getting abstracted from the outputs, and oftentimes you wind up creating like these wrapper scripts to kind of carry outputs from one side to the other. And this is a much cleaner way to do that, much more structured way to do that.
Yeah, I like your blast radius setup. Because just for like, even just the keepers, you're messing around with, you're messing around with storage accounts, and you're like, let me change the value in it, and you're like, okay, cool, and you're going too fast, and you look, you just somehow destroyed your own Terraform state file.
Yeah, because, and if you're like me, you use variables a lot to control what gets fed into your code. And so you might forget that you had like a variable set up as your prefix, and that prefix applies to all the resources within that context. So you changed it innocently enough, thinking, I just want to change this app name, but you accidentally, as you said, changed the storage account name. It gets destroyed. That's where your state was. Things are looking pretty bad now. Okay, so then the last element would be, so we've talked about change rate, ease of management, now blast radius. The last element is actually the management scope. So the only change that occurs here is that we have now basically pushed everything down another level. So now I have this this hierarchical view of applications in general, governance, platform, and the modules directory. The modules directory remains unchanged as it was before. It has all of the different modules that we're collecting. Those are all in Get. And this is sort of an independent area that is stored in Get. Each of those modules is stored individually because each of them need their own versions, their own tags, their own history, as a matter of fact. But what I've added is like the apps. So if I open up apps, then I have what we had before. I have business unit 1, business unit 2, and they have their 2 applications out there. But by doing it this way, I now have a way to sort of organize the ownership of these applications. Well, all this time, BU1 was we had a responsible party for BU1, which was Jason in this case, right? So Jason owns responsibility for controlling BU1. He's in a different remote site. And so now I have a way to very easily subdivide this out and ensure that they have a place that they can go. I can modify ACLs appropriately. I can calve this off and move it to another location. Everything remains intact. It just gives me a good organization to nest that hierarchical ownership under. And if I look under the platform, you'll see, for instance, the admin hub is under there, and there may be others. And maybe I have a whole DNS construct that exists within this. And so the admin hub has all of the pieces that it did before, but now I can set this up to be owned by a different team, and they can manage that. It also means that I'm working at this level on the admin hub. I don't even have to look at or concern myself with what's going on over here under apps. That it's a completely different scope. I may not even have this directory cloned locally, right? Because I just don't need it necessarily. And then I have governance, and governance might be where I start adding things like Azure Active Directory, management groups, monitoring, Azure policies, RBAC even, or IAM. And so these things are very clearly areas that you might have a whole nother group managing for you. Maybe it's security, maybe it's your identity team, maybe it's just your old Active Directory team converted into an Azure team. And then I have monitoring. Maybe monitoring is controlled by a monitoring team. So all of these now become sort of discrete areas that I can control access to, control the lifecycle to. And furthermore, I could actually deploy these in such a way that this is actually built up underneath a, let's see, I could put this inside of a subscription. if you can imagine that. And I might have these things inside of another subscription. And when I create VNets, they obviously live within a subscription for this business unit. Or maybe we have a large application and we want that to be a subscription. So these all become possible for you to manage if you have it broken up in ways that allow you to identify these sections separately for you to cap them off that way. So management scope is one of those areas that is very dependent upon your organization structure. If it were just Jason and I that were managing all of this code and responsible for it, then there's very little reason for us to break it up because it's all being worked on by the same people. But if you have different teams that own this stuff, you may want to set it up so that you only have access to run certain Terraform configuration templates. So that is a good overview of how I structure my Terraform configuration, my projects. I don't always go to this level. It kind of depends again on what structure I'm working within. But I would say that I very rarely live with something that resembles where we started so long ago. So if we look at this flat file structure, I may start this way, but I very quickly move into those other structures to help me. And the most obvious one that I probably land on is, I would say, the blast radius level. I don't always have the management structure that requires that level of division, but I almost always have a requirement to break things up by blast radius, by change rate, by the management ease, because those things get really unwieldy after time. And one other thing that I'll mention too, the state, I know it's been said before, what is large? So you've seen this, I'm sure, before, Jason, when you run your Terraform plan or apply, you have hundreds of resources being created or managed by that state. It takes a good while to actually work through those. And if you are doing things that maybe delete resource groups, and then that resource group contains lots of other resources within it, it's going to take a while to roll through those things. You may want to get to a point where your Terraform code runs leaner, and you may want to even go more divided so that maybe every domain, every tightly joined domain is its own configuration. So I have NetSec here. You might have just VNets as your segmentation. You might have all of a network segmented, but then security is a wholly different segmentation. So it just kind of depends on what it is that you're trying to get out of those runs. If you're trying to get faster, leaner runs, if you're trying to get smaller blast radiuses, tighter change management.
I had a recent client that their internet was so slow that it would just take forever to run, like 5 minutes or whatever, just to run the plan. So yeah. I understand about trying to break it down more.
Yeah, and I've seen that a lot myself. Azure is not the fastest of APIs out there, for sure. So yeah, if you have a really deep plan, a really deep state, it can take quite a while to work through it all. Thank you for listening to us today. I hope this was valuable to you. As always, like and subscribe. Join us on Discord. Ask questions there. Drop some questions in the comments. We're sure to get to them. This was a question right out of our Discord channel. So just kind of proof that we do cover the things that are there, both live for the people in Discord, but also for our viewers on YouTube. So thanks. Have a great day.